Okay, so we are dividing these rational expressions. So what we have to think about, we have to remember back to how do we divide fractions? There's something we have to do. I remember. We have to rewrite the question before we can solve it, right? Or simplify. So what we do, excuse me, is we keep the first fraction exactly the same. Okay, you keep it the same, the first one. And then what I do is I take that division and not yet, we're not flipping yet. We take that division and we change it to multiplication. Okay, so we keep, then we change. And then what do we do with that second fraction? Flip it. Okay. So KCF, keep, change, flip, kind of like KFC a little bit. Just a little bit backwards. So when you divide with fractions, you keep the first one. You change the division to multiplication, and then you flip that second fraction. Then it turns into a problem just like we did yesterday. Okay, so the only difference in what we did yesterday and what we're doing today is we have to rewrite it as a multiplication problem, and then everything else is the same. So once we have our multiplication problem written, we want to go through and try to factor every part of the fractions. Can any of these fractions factor in number one? No. Okay. And so since we don't have any binomials to get rid of, what I want to do is I just want to multiply top times top, bottom times bottom. 5 times x to the third is 5x to the third. And at the bottom, x squared times 10 is just 10x squared. And then we can go and simplify further if possible. I still do not have any binomials. I have one term over one term. So if I can simplify, we want to do it now. What do 5 and 10 have in common? 5. So that's going to turn into 1. And that's going to turn into a 2. And then I have 3 x's at the top. I have 2 at the bottom. Where do I have the most x's? How many more do I have up there? 1. So we can leave our answer as 1x over 2, or more simply, we could just write it as x over 2. So other than having to rewrite it, nothing else is different from what we did yesterday. Okay, so what I want you to do is I want you to take number 2. I want you to go ahead and first rewrite your question. Keep the first fraction, change the division to multiplication, flip that second fraction. Once you do that, I would like for you to go through and try to factor any and everything that can factor. Keep the first fraction, change the division to multiplication, flip that second fraction. Then go through and try to factor anything that can factor. Once you have that complete, go through and get rid of any binomials that you see that are the same, one at the top, one at the bottom. Multiply what is left. And then reduce if possible. Again, we are keeping the first fraction the same. We are changing that division to multiplication. We are flipping that second fraction upside down. Then I want to go through and try to factor. Does any part of this problem factor? No, it's already factored for me. So then let's go through and get rid of what binomials do you see, one at the top, one at the bottom, that are exactly the same. X plus 6. Anything else? No. All right, so we're going to multiply what's left. Top times top. All I have is a 5 and an 8, so when I multiply that, I get 40. At the bottom, I have 10. I have x minus 6, and I have 20. So I'm going to go ahead and multiply that 10 and that 20 to get 200. And I'm going to leave that x minus 6 at the bottom. Can I simplify that 40 and that 200? Yeah. What can I divide them both by? 40. So that 40 turns to a 1. What does 200 turn to? 5. And then that x minus 6 is going to stay x minus 6 in parentheses. And that is how we leave our answer. If you wanted to distribute the 5, you could, but that is not necessary. Everybody okay with that? I want you to try 3 and 4, changing it into a multiplication problem. And then I'm going to go through and factor. Can that first fraction factor at all, numerator or denominator? No? Okay. What about that second fraction? 9x squared minus 16. Those are both perfect squares. So the square root of 9x squared is 3x. Square root of 16 is 4. We do 1 plus, we do 1 minus. Can that 10 do anything? Okay. All right. What binomial do we see that's exactly the same that we can get rid of? Yep. Anything else? At the top, I have my 5, and I have my 3x plus 4 left. At the bottom, I have my 10. Can that simplify any further? Can the 5 and the 10 reduce? They can. I can divide them both by 5. So that 5 is going to turn to 1. That 10 is going to turn to 2. I can leave my answer just like that. Or if you prefer not to write the 1, you can just do 3x plus 4 over 2. The only thing I would say be careful of is some people want to try to reduce that 4 and that 2. That 4 is attached to the 3x with that plus sign. Therefore, it is a term, not a factor, so it cannot be reduced. Everybody okay with that one? Okay. All right, number 4. Again, first things first, I need to rewrite it as a multiplication problem. And just one thing, like especially on the homework, instead of copying the problem as a division and then turning around and rewriting it as multiplication, I might probably, just to save a little paper, just start off writing it as a multiplication, if that makes sense. You can copy it if you want to, but you're just going to have to write it a bunch more times. So starting with number 4, can that numerator factor at all in the first fraction, 4 minus x? No, so that's going to stay the same. What about that denominator, x squared minus 16? What is that? Those are both perfect squares. Okay, square root of x squared is x. Square root of 16 is 4. 1 plus, 1 minus. The numerator of my second fraction, x minus 4, cannot factor. However, that denominator, 12 minus 3x, it can factor because they both have a what in common? A 3. So we're going to pull that 3 out. 12 divided by 3 is 4. 3x divided by 3 is just x. Again, we can only cancel what's exactly the same. What's the first binomial that I see is exactly the same? 4 minus x, okay. And x minus 4. Anything else? No? All right, so if my numerators in both fractions have completely disappeared, what do I have to put up there? What's still up there? A 1. And then in the denominator, I have my x plus 4, and I have my 3 left over. So I'm just going to put it as 3 times x plus 4. Everybody kind of okay with that? All right. We're going to have to talk through number 5 together because there's something a little bit different we're going to need to do. So if you will go ahead and get it copied down and then rewrite it as a multiplication question, and go ahead and work on factoring everything that can factor. Okay, you're not going to finish it because we need to talk about something. But I want you to start the process. Write the problem, change it to multiplication, factor. I'm going to rewrite my problem. Change that division to multiplication. Flip that second fraction. And then I need to start my factoring process. 49 minus y squared. They do not have a GCF, but they are both perfect squares. But be careful with this one. What is first? The 7, okay? You have to put that first because the 49 was written first. And so what would go in the back of the parentheses? The y. And I would do 1 plus, and I would do 1 minus. In the denominator, y squared minus 25. No GCF. Those are also both perfect squares. This time my variable is listed first, so I get to put it first. Square root of 25 is 5. We do 1 plus. We do 1 minus. What about 2y plus 10? What can I pull out there? A 2. And I am left with y plus 5. And then that denominator is just y minus 7. It cannot factor, so I am just going to bring it down. So far, so good? All right, what binomials do we see that are exactly the same? Y plus 5. Do we see anything else that is exactly the same? Do we see anything that might look like it could be close and we might mistake for being the same? We got y minus 7 and 7 minus y, right? So I just want to talk about that for a minute. 7 minus y at the top, and I have y minus 7 at the bottom. I'm going to pick a number, like 2, okay? If I put in 2 for y, let's just see what happens. If I did 7 minus 2, that gives me 5, and 2 minus 7 gives me negative 5. Well, that doesn't completely cancel out, but it does cancel to be what? Negative 1. All right, what if I picked a different number? Let's say 5. If I did 7 minus 5, and then 5 minus 7, does the same thing happen? Yeah. Do you think that would happen every time, no matter what number I put in? That is because these are not exactly the same, but they are what we call opposites. And opposites always reduce to be negative 1. They don't reduce to be 1, canceling each other out, but they do reduce to be negative 1. That is only for subtraction and only when the order is switched. If I had addition, if I had y plus 7 and 7 plus y, those are the same because addition doesn't matter the order. Subtraction does. So if you ever see a binomial that is subtracting and the order is reversed, we can actually cancel or simplify those, but we have to simplify them and we have to put a what in front of our answer? A negative. So what I can do is I can go ahead and cross out 7 minus y and y minus 7. But what I need to do is I need to put that negative sign in front of my answer when I write what's left over. And I usually put that negative sign even with my fraction bar. If you put it in the numerator, sometimes you have to be careful with parentheses and stuff. If you always just put it in line with your fraction bar, you don't have to worry about adding any extra parentheses or anything. What is all left is at the top? 7 plus y and 2. Oops. And then what's left at the bottom? Just y minus 5. So you can simplify opposites. They don't completely cancel out, but they can cancel each other out as long as you stick a negative 1 in front of your answer or put a negative sign, which is essentially a negative 1 in front of that answer. So just be careful with that. Order switched with subtraction only. Does that make a little bit of sense? All right, I want you to try 6. First, I need to rewrite my question. So it's going to be x to the 3rd plus 8x squared plus 12x over all of this. Change that to multiplication, flip that second fraction, and then let's get started. So again, at the top, the first thing I have to do is I have to pull out that GCF, that x that they have in common, and I'm going to kind of hold there for just a second. And I'm going to point down here so I don't have to rewrite everything over again. What numbers multiply to give me 12 and add to give me 8? 2 and 6. So I'm going to do a little bit of erasing. Set up those two parentheses. 2 and 6. My signs are both going to be the same, and they're both going to be positive, right? Okay, in that denominator, 5x squared minus 10x, it's only two terms. GCF first, what do they share? A 5 and an x. Okay. And if I divide 5x by both of those, I'm left with x minus 2. Top, second fraction, x squared minus 4. No GCF, but there are two terms, and they are both perfect squares. So we're going to go x and x. Square root of 4 is 2. 1 plus, 1 minus. And then what about that denominator, 4x plus 8? Two terms. What is the GCF? 4. And I'm left with x plus 2. Is everybody okay with that factoring? Tell me what to get rid of. I got an x plus 2, 1 for 1. Even though there are two x plus 2's at the top, I can only get rid of one of them. What else? X minus 2. Anything else? All right, at the top, I have an x plus 6, and an x plus 2. So I'm going to write those all next to each other. And at the bottom, I have a 5x and a 4 left, which is just going to give me 20x. Can that simplify any further? I have a x times x plus 6 times x plus 2, and I have a 20 times an x. Are those x's being multiplied by other things? Yeah. So this x can cancel with that x, leaving me with just at the top x plus 6 and x plus 2, and at the bottom it's just 20. Is everybody kind of okay with that?